Okay, it is 11 o'clock. I have nobody in class. I guess nobody has questions. I'll just stick around just in case. Just in case. Just in case somebody shows up. There is an exam available. Um, yeah, I'll just. This is sort of. It's already strange enough to like talk uh, while I know that people are watching live, but to see that I'm the only one signed into the Cisco WebEx meeting room and recording the session just for the benefit of anybody who couldn't attend but wanted to just kind of eavesdrop on what happened. This is sort of strange, but that's fine. I'll just uh yeah, uh I'll just work on things. I got plenty of things to work on until somebody shows up. Okay. In fact, let's just do that. Go good. Oh, let's see here. This. Hello. How's it going? Happy to answer a question if you have something. Um, or there's the chat. Just let me see if you can see it this way as well. There's a chat feature because I don't hear you. Just giving you some options. Oh, now I hear. Oh, I think I hear. Thought I heard just some ruffling noise for a moment anyway.
Hello?
Hey, how's it going?
Oh, okay, good. Okay. I didn't know if it was working or not. Okay.
Yeah,
Um,
now I can hear you. I couldn't earlier for some reason. So,
okay, cool. This is just an office hour, right?
yeah, this is just an office hour. So,
Okay. Um, I was just I don't know, over time, I feel I mean, it's been an interesting, past, few weeks, obviously.
yeah.
Um,
Are you doing okay before we dig into just how are you doing?
yeah, I've been okay. The past okay, so for spring break, I ended up going to Nashville,
Okay.
um, and so we were there for what was it, only probably 6 nights, and then they kind of just shut everything down, and so we just went back.
Yeah.
Um, and so I'm kind of we're kind of like me and my friend group. We're kind of three quarters the way into our own like self quarantine
Okay.
right now. So yeah, we got like
Oh,
two,
from
three
having
days
traveled.
left.
Yeah, I see. Okay.
Yeah, having traveled. Yeah, and so that's kind of how it is right now. I'm still on campus. There's a lot of like UP around here is just kind of if they see anybody walking around, they just kind of keep them inside and just make sure they're indoors and
Yeah.
so that's kind of how it's going. They're not. I mean, Res Life is delivering catered food to us because they know that we can't step outside, and so that's probably the only thing benefit that we have from this. And so
Okay.
they send us breakfast, lunch, and dinner, and so um,
Oh my goodness.
yeah, and
Well,
so it's
I guess that's kind of nice. Although you'd probably, I mean, I say that, and you'd probably be like, I'd rather step outside.
I'd rather step
Yeah.
outside.
Yeah.
um,
I'm so sorry.
but yeah, they're trying, and so
Yeah.
that's the best they can do, and so um, yeah, that's kind of just kind of the whole rundown of what's popping off uh here. Are you good? Are you healthy? Or...
Yeah, I'm fine. Yeah, I'm good. As far as I know, like I've had a day here or there in the last 2 weeks where I thought I had some symptoms, but
Mm-hmm.
so if I have had any, maybe I've had this thing, but and just been one of those people who's been lucky to not have a lot show.
Exactly.
But
Yeah.
like, yeah, I've just basically been in my place, talking to no other actual physical people. Just like
Mm-hmm.
just to do something. I like went on a drive on Saturday, but
Okay.
just stay in my car. And so if I mean, I feel like I'm a relatively healthy person, so I'm not worried about me so much as me infecting other people. But I'm like, if I
Yeah.
just stay in my car,
Exactly.
then I could only be getting germs inside my car, right? So,
Yeah.
you know, um, I figured that was probably relatively safe and somewhat sanity wise something, but like
hmm
so I think more than anything else, it's the psychological side of things, but
Yeah.
I think I'm doing okay. And yeah, I don't know. I hope class is okay in this format. At least I can't, I mean, of course you've got all your classes, but like, I at
hmm
least heard one person say having this camera on so that we can at least see you is it's something, So
Yeah.
yeah,
Let's see. I think for me, like for like I won't be needing, but I just have like I think my question is just regarding the format of the exam. I mean, I saw your PDF. Do you want us to print out the exam and then write it and
yeah, good
then
question.
photocopy it for you? Okay.
No, you don't need to print it out. I mean, you can do
Okay.
whatever you want. I mean, what I'm just saying is, take those questions that are part of the exam and make a PDF. So the PDF, you could list the questions, you could not list the questions. If you don't print it out or rewrite the questions themselves, just like say, "This is my answer to question one." That's it. Like
Could so we could potentially LaTeX it?
you can law tech it if you want. You can, yeah. I just anything is fine with me. I'm
Oh, okay.
like I'm just trying to in all of what's going on. Like I know that normally you just handwrite it. So I wanted people to like not feel stressed about law teching in case that for some people, teching is like, oh, it's gonna take me an extra 2 hours. I would rather just write it. So write it and take pictures and make a PDF out of it is cool. LaTeX it is cool. I did try to make an exam where you don't need to like do a bunch of flowchart diagrams or deal with a Minesweeper would probably be a lot of like there are things I try to pick
Okay.
questions where if somebody's going to go the LaTeX route that it's not going to be too painful. Hopefully.
Okay.
So anything is fine as long as I get a PDF from each student with their answers to the questions. I'll deal with it. It'll be extra work for me, but I'll deal with it.
Okay. Perfect. Um. So I think the for some reason, like the homework is like it's flowing. I don't know what it is, but I like the thing is like I have to see I have to see a definition. So I think the biggest thing for me right now is working on like the particularness of like definitions and just figuring out what what they mean, how they can be used or proved.
Right.
There's I think the one that's tripping me up right now is Cartesian product.
Okay.
It's
Yeah.
it's it's a weird one from like
It is.
definitions that we have.
It is. It's
Um,
like this. I mean, there's so many other definitions that we have that are very standard in a sense, and this one's
yeah.
strange enough. But like,
Hmm.
let's recall if you have two sets. You see my writing as well, right? Or,
Let's see.
I don't know if you look at your phone. Do you see what I'm? Do you see
No,
me?
I can only see your face.
Oh, okay. That's unfortunate. I wonder if. Let me try turning off the camera then over here, because I
Okay.
wonder if by doing that, maybe you see. Now maybe you see writing. Maybe not. Like, do you see some blue scribbles?
Mm-mm.
Hmm.
Let's see.
Okay, let me try. Um, I'll stop sharing the screen and I'll try restarting the sharing of the screen because
Okay.
maybe that helps. Let's see. Uh oh, come on. What did I do wrong here? That. So I don't know if you like.
Did it work? Oh, I can't see anything.
Huh. Yeah, that's strange. Give me just a second. I'm gonna sign out and re-sign in. So give me
Okay.
just a minute here. Sometimes that's the problem. So. Oh, do you see anything now?
Oh yeah. Hmm.
Okay, okay. So I don't need to restart. Okay.
Okay.
So let's think. So Cartesian product, I would totally agree with you is a strange one. So sorry. I hope it's okay. I left my camera off. I don't want to like hit a button and then all of a sudden, it's more important you see my writing than my face right now. I think
Yeah, yeah,
if
yeah,
that's okay. All right.
yeah.
So if you have two sets, let me just call them capital P and capital Q. Right. Then we should first of all look at what's the definition of Cartesian product. Yeah, so what should we write in those curly braces? In this region right here.
So for our Cartesian products, I mean, I guess it would it depend on the relationship. Oh no, okay. So we would have, I mean, depending on the format, it'd be some uh ordered pair PQ, for example, uh in uh the cross product of two integers,
Um, in
or
like
maybe hold
this.
on.
See, I think I it's see the thing is right now. Do you see this x that I just drew? You said cross product. I think you meant Cartesian product, right?
Yeah, Cartesian.
But it looks like what's going on here is it looks like you're trying to define the Cartesian product in terms of the Cartesian product. Do you get what I
Oh,
mean? Like, let's just say,
yeah.
just to go, like, I'm gonna pick a different product as an example. Three
Mhm.
times five. Now, if you're explaining what three times five is to somebody who's never had multiplication, this explanation is technically correct, but it's not
Mhm.
helpful to that person to say, "Oh, just replace the three with a one plus two, and then you just have quantity one plus two times five." Now, this is totally correct. It's mathematically correct to say. It's just not
Mhm.
helpful to somebody who's like never seen multiplication, right?
Okay.
So instead of this explanation, it even if it's correct, it's unhelpful. I want to think about how and I'm going to remind you actually how 3 times 5 is explained to somebody who has never seen multiplication. The explanation given is 5 plus 5 plus 5. There are 3 of them, right?
Okay.
But the point is, there's this right here where you're introducing what 3 times 5 is, and there's this over here where there's no multiplication symbols at all. So the
Yeah.
issue that I see with what's being written here is you've got that Cartesian product symbol, and then you have it again on the other side. You can't define a
Yeah.
thing by
With
trying to
yeah.
explain it with the thing, because then where do you start? Like there had to be
Mhm.
the point is, think about when we introduced Cartesian product, there had to be an explanation about what this is without talking about it, right? Because
Yeah.
I'm introducing it.
Mhm. Okay. Let's see. So the order pair Q. Such that P and Q. Oh wait, sorry. P and P. And Q, little Q and big Q. Yeah.
Yeah, that's so this is what comes out of the definition. I mean, the definition, the official definition is, of course, like any other in sentences, but the key part is this here. I mean, this box thingy, that's essentially the definition,
Mhm.
right? So, look, I think the important thing to do with every definition is ask yourself, noun, verb, adjective. And in this case, we have a
Yep.
noun. In this case, when you have a noun, you should always ask what kind of thing, what kind of creature. Is it a set or a function or a relation or a
Mhm.
ordered pair? And this is a set, right? Due to the
That,
curly
yeah.
braces. And then whenever you have a set, you should ask what kind of things live in the set. And in this case, this is a set of ordered pairs,
Order pairs. Yeah.
right? So these are the things to ask yourself all the time. And then, especially in the case of sets, I think it's important that you build an example, because I know that these things are can be confusing, but you've got to build your own intuition for what belongs here. So this is, I think, a super important, very helpful, concrete step. And so to build an example, you've got to make a set P first, right? Because you're supposed to start with 2 given sets P and Q. So
Mhm.
you got to just actually make a set, right? So like maybe P is 1 2, and maybe Q is let's just go with 2 3 4. Right? There's nothing about P and Q where they don't have to be disjoint. Um, they can be disjoint. One set could be filled with numbers and the other set with people. I mean, anything's possible here.
Yeah.
But then we should, based on these two specific sets P and Q, maybe I'll underline them in red. Based on these, we should write out what this set is in roster notation. You get what I mean by that? Like just
Mhm.
commas to build a sense of what's going. It helps clear up what's happening for one thing.
Yeah.
So what,
Uh,
based on
let's
how the set is written up here in green.
Oh yeah. So I mean, one option would be 1 2, 1 comma 2 ordered pair.
Yeah.
Um, an ordered pair 1 3, 1 4, and then yeah, 2 2, 2 3, and 2 4.
Okay. Yeah. So this set right here, P Cartesian product Q, has cardinality 6, I believe. Let me just
6. Yeah. Mhm.
1, 2, 3, 4, 5, 6. Yeah, I just underlined 6 ordered pairs.
Okay.
So of course, because this was a small enough example, there were only 6 ordered pairs. There were only 6. Um, we wrote down all 6 of them separated by commas, slapped into some curly braces. Now sometimes you're going to have examples where the amount of stuff is just too much. So one thing we could have done even in this example is like this ordered pair 1 4. I'm going to underline this in black. We could have just said this belongs to P Cartesian Q, right?
Yep.
Now it would be an error if we said P Cartesian Q equals set ordered pair 1 4. this is wrong, right? This is not good because this is suggesting that there's literally only one ordered pair,
Only one. Okay. Okay.
right? So just to talk about like in the black box, this is like there is an ordered pair that's in here. Um, and so why is there a one in the first spot? Well, it's because of the one that's over there, right? And why
Hmm.
is there a four in the second coordinate? It's because whoop right over there. there's a there's a four that belongs to Q, right?
Yep.
So if you have an element of any element of P and you have any element of Q, you just stick those together um, and create an ordered pair. First coordinate came from P, second coordinate 4 came from Q. And so because of this example, I want to think of as another example, let's just say that your P was a set of reals. And I'm changing it up now, right? So no longer this P and
Okay.
this Q. I'm just a new P and a new Q. And so let's just
Hmm.
say that the set Q was the set of all rationals. So I guess what I want to ask is writing it in this the format in red is not um, is not so good only because it'll take forever. So
Yep.
can we write something that looks like the black box to just like so that we build our intuition of what belongs to the set? So something I'll write a scribble there belongs to P Cartesian Q. So here's where I want to ask you where this scribble is. What could I write there instead?
So the scribble will be um. It's not. Is it? I mean, okay. So what I went straight to is it this set of is the order pair of set of reals to
Okay, so sure.
rational numbers?
If you want to write the set out in this format, we can do that,
Hmm.
right? So PQ such that little p is in. Now I could write a capital P, but I could replace the capital P with just R,
Hmm.
and then Q in, and I could write this capital Q, but I could just write this symbol instead and put that here. So
Yeah,
staring at this, tell me a thing that I can put here where this squiggle is.
that belong. Oh, an example that belongs in.
Yeah, an
Oh, okay.
example of something that belongs
Oh,
to the set.
it could be four order pair four comma one half.
Okay, cool. Yeah. Um, what else? So that works.
Oh, I mean, oh, there'll be a yeah. There's okay. So yeah, we get -6 comma uh one third.
Okay. Now I want you to exercise. This is correct. There's no error,
Yeah.
but I want you to focus on trying to make an example that's even better. I know you're like,
Okay.
wait, there's really better examples and worse examples. Like you can put
Yeah.
value judgment on examples, and
Hmm.
actually, for the idea of explaining math, whether you're explaining it to somebody else or you're explaining it to yourself, yeah, there are better examples and there are worse examples, and I don't mean like more tedious or like harder. What I mean is like examples that help really clarify what's going on. So the point I want to make right now is you have no errors here. This is great stuff. The thing is, when you said -6, I asked myself, is that in that set? Is that in the set of reals? And I go, yeah, -6 is a real number. Then you,
Oh, reels. Yeah. Yeah. Not integers. Yeah. That's what I was thinking. Yeah. Reels.
yeah.
That's probably why. Yeah. Okay.
So I think what you said isn't wrong, but it's
Hmm.
I think the examples you've provided so far would be the ones I would have wanted had there been a Z there.
Yeah. Hmm.
But because we got a reals here instead, like what's is there a is there a hi Izzy? Thanks. Oh, okay. Well, we just lost. So I guess the what am I trying to ask? It's like, yeah, since there's a reals here instead, could we come up with another example? Hi, Izzy, welcome. Um, is there another example of an ordered pair that we would want to mention belongs to P Cartesian Q? You know, to be like
Yeah.
a serve as a better example.
Okay. So, um, taking off that -6, we could
Sure.
do was it 2.17?
Yeah, sure, exactly.
Yeah.
That's great. Yeah. Now it turns out 2.17 belongs to Q as well, and so for me, like, but it's fine. 2.17 belongs to, so this number here, this first coordinate belongs to both that set and this set, but
Mm,
because it turns out to be that every rational is a real, or in other words, the set of rationals is a subset of the set of reals. It's kind of nice to try to come. So I like your example. I think it's a better example, but I want to think of an even better example. So I'm so greedy, right?
an even better example.
Yeah, I would love to have the first coordinate be an element of reals that is not an element of
Okay.
Q. That's what I mean by better example.
Okay. I mean, I guess pi, right?
Yeah, pi.
Mm-hmm.
Pi, then one third. So it's sort of an example like this to me, as which is an element of, yeah. So this is I gotta move this like that. Okay. Um, this is sort of a really nice example. Do you get what I mean? That like really
Yeah.
clarifies what belongs. So our earlier example, still in red up there. Let me scroll up a little bit. Um, it made sense in our earlier example to write out all six ordered pairs that were elements of the set because there
Mm-hmm.
weren't so many. There were just six. And the problem in our new example down here with the new P and the new Q is that there's an infinite number of ordered pairs. So instead of trying to write it in the comma separated format, we just wrote down some ordered pairs that belonged, right? We've got, if I circle them in green, we've got that one, we've got that one. These are all elements of this Cartesian product.
Yep.
And I think so to really kind of get to what you're saying, I appreciate the sort of question or the concern maybe of like, I have a hard time with Cartesian product. It's with any definition, Cartesian product included, it's good to do a thing like this to help build um, intuition for what belongs, right?
Mm-hmm.
And then I think the next thing to do after this is, let me take your copy of the set definition over here. I'm going to just kind of copy paste this to the bottom of this page, or top of the next page, let's just say. In addition to that, I want you to look at how this set is written, and by how I mean, like, I mean this, what's in the green box. And it's also good for you to translate writing this set in another format. So I'm going to, how about this as a DK? I'm going to ask you to write down P Cartesian Q using the other set format, and then and I'll take a question from Izzy in the meantime. If you can fill that out, I also want to connect. So we'll talk about how you fill in, you know, where the green squiggle is, and then we'll also, once that's done, we're also gonna, like, we'll talk about it, and then I also actually want to connect it back to the example that we did earlier, because I think it's nice to like keep connecting examples to the more abstract thing of the generic definition. Is it, if that makes sense?
Okay. You want me to use the one that included the reals and the rationals?
No. Just stick with like a this P and this Q. Just so P and Q are just some sets, and we don't even know which sets. I just want you to write. So don't look at any specific P or Q right now.
Okay.
What you see on the page is all you have. P and Q are sets. We don't know which sets, but I want you to focus on the different set notations is the point right now. So
Okay.
this is what's in the green box is written using one of the three standard set notations. I want
Mm-hmm.
you to convert this into another set notation without using a specific P or Q. So what I'm asking you to do is all that stuff in the red box, ignore it. Right now, what's drawn here in blue, that P is, oh, sorry. What's drawn here in blue and the Q was the set consisting of 2, 3, 4. We don't have that right now. I want you to ignore that. We don't have that. We also don't have P as the reals. We don't have Q as the set of rationals. Just P and Q are some sets. We don't know which sets, but I want the task that I want you to do should not involve what specific elements belong to P and what specific elements belong to Q.
Okay, cool.
So take a moment to do that. I'm trying to buy time, and then I'll answer Izzy's question, and we'll just kind of go back and forth here. So I see that a mic has been unmuted, but I don't actually hear anything, Izzy. So I don't know if in addition to unmuting within the software, you might have to do something like in the corner of your screen. There is also, it's not as ideal, but there is the chat box, which I lost. Where did it go? Chat. I mean, it'll be way more ideal to be able to hear. Yeah, so yeah, I saw that you momentarily muted and unmuted within the software, but I just wonder if in the corner, I don't even remember if you're on a Mac or Windows, but like in the lower right corner of Windows or in the upper right corner of the Mac, there's like, so not built into the Cisco WebEx software, but there might be a setting. Um, Setting within like the operating system in a sense. Alternate option, if you want it, is you can call my office phone number. I have it currently forwarding to my cell phone, so I will write down my office phone number if I can. Uh, office phone number 608 785 6613. So it's just like if this audio is not working this way, it's a way to make audio somewhat. I mean, it's something. Or you're gonna exit. Okay, that works too. Hello, welcome. So I cannot. Yeah, you're right. I cannot hear you. It is an option if you'd like. If it works for you, if you want to call my office phone number, that will forward to my cell phone. So that could be the audio link. It's not. I mean, there's only so many things that are ideal. So I don't know if that's an option you want to pursue or if you want to dig into the settings because I can on my screen I can see when somebody has unmuted their mic within the software, but then there's usually other settings like within the computer itself that also need to be set up right. Like on my own laptop, I'll just comment there's like a button that looks like a slash with a microphone picture on it, and if that button's not set right, then the mic's going to be off no matter what anyway. guess I'm sitting here assuming that you can hear me, and I need to probably write. Can you hear me, or do you want to type your question? To type a question. Just I want to give as many options. Okay, I'm just trying to give as many options as possible. So you could call, you could type a question in this chat. Um, I'm sorry. All right, hello. Okay. If you heard me before, then maybe you're now hearing me twice, like once through your phone and once through your computer. So you may want to mute um, or like lower the volume on your because it could be annoying otherwise. I'm trying to think of everything. Okay, so you can at least still see me, right? If you're signed in, you can see me right on screen. Okay, so yeah, question. Sure. Question about proof by cases. Yeah. So, right. So this is one of these places where, and I'm not trying to be unhelpful, but like for proof by cases, there's never like oh, this is the situation you like. It's not. It's sort of like integration, where like sometimes proof by cases is the right thing to do, and sometimes um, you kind of have to guess at it, which is a little awful, right? But you get what I mean by like comparing it to like the different ways to do integrals. You just so like if let's say yeah. Yeah, that's fine. So let's say you have a setup. So I'm gonna draw a little bit of a cartoon on screen. So let's say you assume some things because the setup of your proof allowed that. Like let's say you had like if blah then blah or something, right? So these things like in the red box here, let's say you assumed so out of a little bit of laziness, right? Like the stuff that's in the red squiggle box. Um, yeah, if you're proving an if, then you assume this, and then you're trying to reach, of course, this conclusion here in the blue squiggled box. And if the way you reached it was like you had identified a situation, like so you identified for yourself a separate proposition where you're like, hey, I've got this other thing. No, I know this one in red is normally called P, so let's stick with that. And this one in blue is normally called Q. So let me just to pick another letter. Let me just call it, I guess, R. Like so, let's say you got like you're saying R. When R is true, if you add this assumption in, you can take this along with this red box stuff and you can get to Q. But then you also started with R being false, in other words, not R being true, and you combine this with this and could reach the conclusion Q. Is that am I understanding the setup of and by R in your case for a Minesweeper was like there's a certain cell where you assumed the cell was safe and you got to Q and you assumed the cell was not safe and you still got to Q. Yeah, then that's fine. So that's a valid proof by cases. As long as you reached Q, um, basically oh sorry I used the wrong keyboard to so like if you assumed P and you assumed R, and then these two things led you to Q, and then you assumed P and you assumed the negation of R and you reached Q, then you've this is the proof by cases way of having proved that P implies Q. So I know you're like you might be almost annoyed that I keep phrasing it. I'm trying to not say any Minesweeper stuff right now. Are you because and I'm just doing that because this idea of proof by cases, of course, applies beyond just Minesweeper. So if your R was yeah like a certain cell is safe and your not R is that same cell is not safe, that works. And just to the last thing I'll say about it because I think we're clear about this, but I just want to say in the handbook available online, the way I think the notation was an H1 and an H2. So in this case, it's like your R is your H1 and then your not R is your H2. The point is you've got to make sure that you've covered all your bases, right? So sometimes there's two cases because you're saying like either this is true or the opposite of it's true, and so then you'd have a proof by two cases. But sometimes you have a situation where one of three things can occur that you like identify three situations. But yeah, the most common, I don't want to say common, like it's like a proof by cases is found in the wild this way, but like the at least the first easiest way to think of proof by cases is a situation where you have two cases. So it's got to be a thing and its opposite. Sure. Yeah. Good question. So if you identify the two situations and say one of these two things has to be true, and you reach the conclusion Q in one case, but you don't reach the conclusion Q in the other case, that's not a complete proof by cases, right? Because the point is you've got to still reach the goal, the conclusion Q. Now, if you reach the conclusion Q in one case and you validly argue that the other case cannot happen, so at first it seemed like it could happen, but in the end there's some reason why it creates some conflict, some contradiction. So this second case we thought it happened, but it actually can never happen, like it's literally impossible. That's fine, but you do actually have to reach the conclusion of Q in every possible case, right? Because if you don't, it's sort of then this proof by cases become like magic words you where you get to like assume something additional. But that's not the point here. The point is you let's say you reach a point in your proof where before you think of proof by cases, you're like, okay, I'm stuck. I can't get to Q. But wait a second. One of these three things has to be true, or one of these five things has to be true. And no matter which of these five things I assume I reach Q, then you know that Q is going to be true. But you've got to reach Q in all five cases if there are five cases. So if you only reach the conclusion Q in one out of the five cases and don't even address the other four cases in a sense, then it's like then that's sort of cheating. It's like adding an assumption, but you don't want to just add an assumption just because. So I hope that clarifies a little bit the layout of what proof by cases is doing, right? It's like I've heard this phrase a lot. This is like 2 decades ago. I heard somebody one time say to me, "You're damned if you do, and you're damned if you don't." Like some kind of situation where somebody's going to be angry with you if you do something, and angry with you if you don't do something. So no matter which way, you're screwed. That's sort of a proof by cases. Like there might be a different reason that somebody's going to be mad if you do something versus if you don't do something, but and then the only other thing I guess to address to your question, you sort of also asked when do you use proof by cases. So while most of the time it's not too certain, sometimes every once in a while you have a situation where you have the setup. I shouldn't use P's and Q's. I'll use A's and B's. You might have like you might know that A or B or C is true. It's rather rare that you know a disjunction is true, but if you did know that a disjunction is true, very often you're going to break into three cases here where you assume A is true, or then separately you assume B is true, you assume C is true, and then you still need to reach your conclusion in all three cases. Yeah, you're welcome. Okay. All right. Bye. Okay. All right. So that was on the phone. So you only heard one side of it, but I did try to, just in case you were eavesdropping, I tried to make it so that like it. Well, whatever. Did you come up with a thing that would fill in this spot?
Yes. I have some variable h.
Yeah.
Um, oh, what's that vertical bar called?
You can call it such that,
Such that okay,
because the
such that
colon would be yeah.
there exists p and p, and there exists q and q, such that h equals ordered pair pq.
You got it. Okay.
Okay.
So here's the thing. Then from this, so these are both like what's on this line, what's on this line. These are both technically could have been used for the definition. Now,
Hmm.
one of these was presented as the definition, and one was not, right? Because we got to have
Yeah.
one official definition. But the point is, I think the first one, this way, without any exist symbols, it's a lot easier to process what the heck is going on, right? Like it's easier to stare at the version that's in the green box and go, oh, I see. P Cartesian Q consists of ordered pairs where the first coordinate P has to come from capital P, and the second coordinate, which we called little q here, has to come from capital Q. It's like a lot easier to get an intuitive sense of what belongs in the set. In fact, it's this version of the notation that we used back here in this red box, right?
Hmm.
This other version um, that's not in the green box, the one that you just wrote down and told me about, is I don't think it's as easy to, in my opinion, it's not as easy, it's not as intuitive to note it, to stare at what's written in black and go, oh, I see what belongs to the set. It's much harder to tell, in my opinion. But it's way better for proof. So let's say that somebody tells you H belongs to P Cartesian Q.
Hmm.
Then, based on how this is written over here in the black box, then what can we conclude, right? So if you know H belongs to P Cartesian Q, and then staring up at how we just wrote the set in a new format, this should tell us.
That we know that since h is in q, we know that there exists p and q, and that there exists q and q, um, such that yeah, I guess h and h equals p equals order pair pq.
Right. And H
Mm-hmm.
is a placeholder variable, so I wanted to start with this, but the same would happen. Literally, the same would happen if instead of an H, let's just say it was, I need a new letter. I'm going to go with a S, I guess. Right? Same deal. If it was a little S instead of a little H, same deal. I hope that makes sense, right?
Yep. Mm-hmm.
Um, and this goes backwards too, right? So like if you had this box, if this is what you knew, then you could conclude that S belongs to P Cartesian Q.
Yep.
Okay. Now, what I want to do though is I want to connect it to what we already said over here, up here. So I'm going to just copy paste this messiness that we had from our specific example. So I want to note that while we did this computation to be as um, just to build an intuition for what's going on,
Mm-hmm.
um, we had already said. I'm gonna actually erase this because I need to get things a little closer to each other. Sorry, I'm not good at this yet. uh, okay, so let's get rid of that thing that doesn't even make sense. Okay, so I'd like to compare over here. Just part of the valid reasoning we had earlier. We had said right here, ordered pair 1 4 belongs to P Cartesian Q, right? We said that before. And so take a look at compare this to what's right there, right? So maybe I should choose a new color. I'm going to use a green box. That's, I think, yeah, an unused color. So this green box and this green box. Okay. Do you see how both of the green boxes end the same way? They both end is a member of P Cartesian Q, right?
Yeah.
So the thing that's not the same is before the membership symbol, there's either just a single lowercase s or there's the ordered pair 1 4. And so what I'm going to do is I have some space over here. I'm going to write. Probably green doesn't show up as nicely, so let me do this. I'm going to write, instead of the S that we see up here, I'm going to replace it with 1 4. Basically, every S, every little s from up here, down here, I'm going to replace every little s with the order pair 1 4.
Yeah.
So there exists. So order pair 1. This is an if and only if technically, so I'll draw the arrow both ways. But there exists a P in P. There exists a Q in Q, such that there's the S, right? And then we're going to replace this S with order pair 1 4 right now. Order pair 1 4 belongs to P Cartesian. Sorry, no, I'm not doing this. What am I doing? That's not right. S order pair 1 4 is equal to PQ. So I want you to stare at. Let me scroll back up just a little bit. I want you to notice that what's up here, there were two places there was little s. And in both cases, down here, in the lower right corner, the little s was replaced with order pair 1 4. And that's literally it, right? Like no other changes. Yeah. Like literally no other changes. It just this red circled S and that red circled S were replaced with order pair 1 4. Nothing else. And it was informed by the two green boxes basically looking grammatically the same. So by staring at what was the same and what was different, I was like, little s should be the order pair 1 4. Are you with me?
Yep. That makes sense.
Okay, so then now that we have this, I'm gonna rewrite this box just a little bit. All I'm gonna do is, you see where this capital P is right there? I'm just gonna replace it. Because in this specific problem, so I know up until now I've asked you to ignore the capital P and the capital Q, because the argument that you were supposed to make at the top of the page, which you did, doesn't depend on the specific P or the specific Q. But I want to now connect all these ideas. So I'm going to replace the P, where the arrow is, with this. 1 2. Set 1 2. Right? Does that make sense?
Yeah.
Same deal. There's a Q right there. But instead of writing a Q in this blue box that I've now also made a black box around it, like we can just replace that Q with the set 2 3 4. So I'm just going to erase the Q symbol here and put in a 2 3 4. And now stare at this. Check it out. The order pair 1 4 belongs to P Cartesian Q if and only if there exists a little p in the set 1 2. There exists a little q in the set 2 3 4, such that order pair 1 4 equals order pair PQ. That is totally true, right?
Yeah. Well, that works.
So it just, all I'm trying to do is just connect. I'm connecting both of the definition ways of doing this. There's sort of like the, I would say it this way. There's the original definition, right? Original definition, which had the set written in, in its one format. And from this, we talked about a specific example. And then there's the redone notation way that you did. I think you used an H, so I'll just kind of stick with that. This is kind of cartoon right now. Um, and these are of course connected to each other. This is not an if and only if arrow. I'm just saying that these are conceptually connected because this is how we change the notation back and forth between sets. But we looked at this specific example here of the ordered pair 1-4 belonging to the set. And then the whole point is right now, it's the same damn ordered pair here. The connection here is that little s was 1-4. And so it's the same example. And I'm just trying to finish the loop off here.
Yeah.
So this is not like a flowchart diagram. This is just each of these four boxes represents a concept, and on the left you see the generic concept, and on the right, in each case, you see the specific concept or the example, and they're all connected to each other.
Mm-hmm.
But like this is all there is, right? So like I think the important thing to do, even if it's a slow process, is especially with any definition that's like more confusing, you kind of want to dig through it this way. Like you see how there was like all this discussion over here was generic, and I appreciate you asked like, what do I need to use a specific P? And it's like, no, that part on the left does not deal with the specific set. It's the example connections here that deal with the specific set P and Q.
Mm-hmm.
Right, and
Okay.
that's all there is. Because if you have this, and then you have like what's up here, like what's in I'm running out of colors, like what's in this blue box of using versus proving membership in the Cartesian product, there's nothing else. There I can't think of any other tasks that relate other than what we've done.
Okay.
Okay, I gotta run unfortunately because it is the end of class. So
Okay. Yeah, no problem.
all
Oh
right,
yeah, thank you so much. Yeah.
yeah, you bet. I'll see you later.